Yes. So tonight we're going to go over concepts of muscle contractions, which include understanding the basics that initiate muscle contraction, sliding filament theory. So we're going to discuss a little bit of sliding filament theory. And we're going to go over concentric, eccentric, and isometric. And also we're going to work on agonist, antagonist, synergist, and prime mover. And I have a couple of opinions on whether or not I have opinions on how much of sliding filament theory may be on the exam, how much of eccentric, concentric, isometric may be on the exam, etc. And I'll share those opinions with you. I do want you guys to know that I am not sure how much of that they're going to ask you, but we have to start somewhere, right? So I don't want to overwhelm you with information at a depth, at a layer that is much more than you need. And that is definitely possible with something like sliding filament theory. Also with like the whole synergist thing, like in the neck, for example, when you flex your neck or extend your neck, there's 4 muscles in the front, 4 muscles in the back that act as concentric or eccentric groups of muscles. Some of them in the concentric group in the front can also act as synergists. And there are different opinions in different texts and different books as to whether or not, for example, the SCM is a prime mover or whether it is a synergist. So some things like that, I actually would prefer not to get into because I don't want to confuse you guys. And I think that in those cases where you may be trying to determine in that specific case, what is a synergist, what is a prime mover, and what is an antagonist, I think the best approach for you is process of elimination. So looking at a group of muscles and saying, these are the group of muscles that the question is talking about moving in this direction. So this would be concentric. So they would be the prime mover, and just leave it at that. And then the other questions that don't list those muscles, you have to either determine if they are eccentric or if they are not relevant to the movement, or maybe they're the synergist, right? So you can at least eliminate a couple answers that way. But with like anatomy and kinesiology, there's always disagreement. There's always like different schools of thought. Some people say, for example, there are 11 body systems. Some people say there are 12 body systems. Some say that, this muscle or that muscle may be a synergist. Some people say that it's both a synergist and a prime mover. I saw an opinion today with the squat, which we're going to look at later. Someone said, a highly respectable blogger said that the hip flexor, the iliopsoas, is not a player in the squat at all. And I'm like, how can that be? The fibers are shortening as you flex the hip. The fibers are shortening. How can it not be firing? So, and everybody else disagrees with that. So there's always areas that are gray, where there is disagreement. There's not that many of them. So what I'm doing is I'm focusing on the areas which are more black and white, which are agreed upon. And the gray areas, I'm going to try not to get into those too much. Okay, so speaking of gray areas, I want to start the presentation tonight with a sample MBLEx question from the FSMTB. When you look at the FSMTB kinesiology module review, kit, it gives you the different sections like components and characteristics of muscles, types of proprioceptors, and then it gives you little sample questions for each of those sections. right? And I found this question to be really pretty lousy, and I want you guys to be prepared for this. So the reason it's lousy is because of the structures that they list, they're asking you about. And because the real answer, if they're really asking you about the bulk of skeletal muscle, the real answer is not listed. If they're not asking you about the bulk of the muscle and they're asking about fibers, it'd be the sarcolemma. But fibers and the bulk of skeletal muscles are two different things. Fasciculi also are different from fascicles. So fasciculi are not the muscle fascicles. You guys, hopefully you remember this. Muscles, here's the bulk of the muscle. Like I'm calling the bulk of the muscle in this question, which is like, this is not an anatomical term. Bulk of the muscle. And bulk of skeletal muscles. Like what is the bulk of skeletal muscles? Does that mean like of all, 100 whatever muscles there are in the body, most of them? Or does it mean the biggest part of the muscle, like the belly, the gaster of the muscle? So if you look at the bulk of the muscle or the belly of the muscle, you see that it's made up of several fascicles, right? And fascicles, here's one fascicle, here's a second fascicle, a third fascicle, a fourth. This is a fascicle, this whole thing right here. Each fascicle has several muscle fibers inside of it. Muscle fibers or myofibers, muscle fibers or myofibers. Many of the muscle fibers or many myofibers make up one fascicle, right? And around the fascicle, there's I believe a sheath called the endomysium. And then around the myofiber, each individual fiber, there's a sheath called the sarcolemma, Around the whole bulk of the muscle belly, there's the epimysium. There's also fascia that covers the whole muscle, right? So the question is, what is the name of the connective tissue surrounding the fibers, the fasciculi, and the bulk of the skeletal muscles? Well, first of all, the fibers, what surrounds the muscle fibers right here. This is one muscle fiber containing many myofibrils, one muscle fiber in a group of muscle fibers that make up one fascicle. So the sheath, the membrane that surrounds the myofiber, muscle fiber, is the sarcolemma, right? So that's one of your choices, sarcolemma. Name of the connective tissue surrounding the fibers. And then it goes on to say also the fasciculi. All right, now fasciculi is the plural of fasciculus. Fasciculi is not the plural of fascicle. It's not the plural of fascicle. Fascicles is the plural of fascicle. I looked all of this up because I was like, what is this question? They're jumbling in like three structures and not giving what I think is the correct answer, which is epimysium. So fasciculi is actually bundles of muscle fibers and nerves and veins and arteries. So it's more structures than just the fasciculi, right? It's like fasciculi and innervation and vasculature. And the bulk of skeletal muscles. So what connective tissue also surrounds the bulk of skeletal muscles? So the bulk of skeletal muscles is not surrounded by the sarcolemma. Sarcolemma only surrounds the myofiber. It does not surround the bulk of the muscle, and it does not surround the fascicle. They're not even talking about the fascicle. And if they are, they misspelled it. So is it fascia? I mean, fascia is not acknowledged in any of the textbooks or any of the websites that I've consulted. It doesn't say that fascia surrounds myofibers and fascicles and the belly of the muscle. It doesn't say that. Everybody, please hit your mute button. Somebody's unmuted. But it makes sense to me because fascia is a structure, right? Epimysium is a fascia-like structure that's around the belly of the muscle. Sarcolemma is a fascia-like structure that's around the myofiber. But I don't believe that fascia is the correct answer. Because fascia is not defined anywhere as being the sarcolemma. The sarcolemma is not defined as being fascia. Neither is the epimysium. It's kind of insinuated that fascia is separate from these outer membranes. Okay, so it's maybe not fascia. Is it the sarcolemma? Well, the sarcolemma is too specific because that only refers to the wrapping of the myofiber. It doesn't, and that excludes the wrapping of the belly of the muscle and the wrapping of the fascicle, which I think they're not even referring to the fascicle correctly. We know it's not a ligament and it's not an aponeurosis. A ligament is ligaments are not attached to muscles, right? So that's not a muscle structure. An aponeurosis is, we didn't discuss this, but an aponeurosis is a type of ligament. So that also is not correct. So it's definitely not C, it's definitely not D, because those are not muscle structures. It's either fascia or sarcolemma, and neither one of these is, like, fascia is not specific enough because fascia doesn't include the sarcolemma, and sarcolemma is too specific because there's no sarcolemma around the bulk of skeletal muscles or around the fasciculi. So which one of these two is correct? The bad news is I don't have the answer for you. I actually Googled the question and searched the FSMTB questions that we're going to peruse tonight, and it's not anywhere. Can everyone please mute themselves? I just muted everybody. I heard something. I asked you guys to mute. Whoever's unmuted did not mute. I muted everybody. Then whoever was unmuted the first time unmuted themselves a second time. All right. Huh? What's going on?
I think A.
Say what?
A.
I don't know if it's A. I don't know if it's A.
Fascia?
I don't know. I don't know. I don't know. The way that the question is phrased and the choices given, they do not correlate strongly enough for me to say that it's definitely A or definitely B.
Okay.
So what I wanted to show you guys is that the way that the question is phrased is unclear, and the answers don't correlate in my mind. So you may run up against something like this, and you're going to have to decide for yourself how to answer it. I'm sorry that I can't help you beyond this, but one thing that this question is doing for us is it's forcing us to review our histology, our muscle histology for skeletal muscle. So at least that's good. Okay, so on to the concepts of muscle contractions. So there are three goals, and the first one we're going to cover is the basic steps that initiate muscle contraction, which is called sliding filament theory. Now, sliding filament theory has like 7 steps, and there's a whole bunch of chemical processes, and we're not going to go over all of those because I don't think that they want you to know those. I don't see any specific exclusion about those specific chemical processes, but there is a reference. Okay, who's unmuted again? Mint, are you unmuted?
No.
Well, then how are you talking to me if you're all right? Whoever's unmuted, hit your mute button. That's like something out of a Richard Pryor movie, you know. Okay. It says not expected to name actions, attachment sites, and innervation for every muscle in the body. Candidates always benefit from a strong knowledge of muscular anatomy. Understanding mechanics of muscle interaction will be more important than memorization of all the muscle attachments. Candidates should have an understanding of kinesiology tools like the application of range of motion and assessing and reassessing joint mobility. I haven't taken you guys through joint mobility. I should do that next week for you. Okay, so it doesn't specifically rule out like the biochemical aspects, like what is ATP and what do the phosphate groups do to the myosin heads. It doesn't rule that out for sliding filament theory, but based on the specific, like what is specific and how broad the specificness and the broad nature of some of the questions, I don't think they're going to ask you anything really specific beyond what we're going to cover tonight. So if you look at a muscle fiber, so this is one muscle fiber, a myofiber. It has stripes, right? It's a what do they call that? Striated. And the striations, they actually come from this area right here where these different filaments overlap. These are actin filaments and these are myosin filaments. And you know that actin is thin and myosin is thick because the letter A comes first in the alphabet and the letter M for myosin comes later. So I remember A as being like thin and then M as being thick, just because of their order in the alphabet. And it's these overlapping areas which give a muscle its striated appearance. A sarcomere, this whole thing is a sarcomere from this Z-shaped line, it's called the Z line. From this Z line to the next Z line is a sarcomere. And sarcomeres are stacked end to end, they're joined end to end like the cars of a train. And or like cars in traffic. So as a result, you have small sections that contract one at a time, and you know we want them to contract sometimes all together, like in the case of I don't know, like a short muscle in the palm of your hand, or maybe like some of the small muscles in your face. You want the whole thing to contract all together. And sometimes you want only sections to contract, like the hamstring, which crosses the knee joint. So it flexes the knee, and it crosses the hip joint. So it extends the hip, it extends the leg back behind the hip, right? So the hamstring muscles contract, their fibers contract separately. The top part of the hamstring up near the glute, up near the hip joint, they contract when you extend the hip. And the bottom section of the hamstrings, those contract when you flex the knee. So you can extend the knee and extend the hip, reach the leg behind you as you're straightening the knee. And that will cause eccentric contraction or lengthening of the lower part of the hamstring muscles, and concentric contraction or shortening of the fibers in the upper part of the hamstring muscle, which I think is pretty cool, because that means that muscles can actually contribute to movement of two different joints in directions that are kind of oppositional to their muscle fibers, right? Where one is shortening and one is lengthening. So I think that's a great intelligent feature of the body. And that is due in part to the separation of the sarcomeres from these Z lines, and the Z lines connect to the actin filaments. So what happens is when it's time for the sarcomere to contract, the Z lines, they get pulled closer together. They're pulled because they attach to the actin, and the actin is pulled by the myosin fibers. The myosin fibers, these little heads on them, they grab the actin and they pull them. They do like a come hither. They pull them and the two Z lines come together. So now let's look at, I didn't mean to look at this next, but we're here. So let's look at it. So here's a Z line or a Z disc. I don't think that they're going to want you to know the Z discs, the H zones, the M lines, the I bands and A bands. I don't think that they're going to ask you about those, but know that the Z discs, I think they're also called Z lines. Know that the Z discs are the ends of the sarcolemma that get pulled towards each other when the myosin and the actin start to slide past each other. And that myosin and actin slide past each other because the myosin is pulling the actin. So let's look at let's get a video, because the video makes it really clear. If you go into this presentation, which I haven't named yet, I'm just calling it Kinesio 4423. If you go into this presentation on this slide, this is like the third or fourth slide, there's a link up here. And if you open the link, it opens to, why is that so small? It's so funny. It opens to the exact spot in the, wow, this is weird. It opens to the exact spot in the YouTube video at like second 23 or something. After you get past the advertisements, of course. Dismissed. Okay, so
of muscle fibers. Muscle fibers are composed of bundles of muscle fibers. Muscle fibers are long cylindrical cells containing several nuclei. Muscles will contract or relax when they receive signals from the nervous system. A neuromuscular junction is the site of the signal exchange. This is where the synaptic bulb of an axon terminal and muscle fiber connect. Muscle fibers are composed of many myofibrils. A myofibril contains contractile units called sarcomeres. Sarcomeres run adjacent to one another down the length of the myofibril. Each sarcomere consists of alternating thick and thin protein filaments, giving skeletal muscle its striated appearance. The muscle contracts when these filaments slide past each other. The thick filaments are myosin, which are anchored at the center of the sarcomere.
they only show the
thick filaments
contraction
are
once, which is
myosin
kind of
contracts when these
kinda
filaments
lousy,
slide
but
past each other. The muscle contracts when these filaments slide past each other.
one more time.
The muscle contracts when these filaments slide past each other.
So that's pretty much it in terms of what we need. Let's listen for 60 seconds more, just so we get some of the deeper information, which a lot of it you're not going to need, but let's just be familiar with like some of the terms. Let's just hear some of the terms.
The thick filaments are myosin, which are anchored at the center of the sarcomere, called the M line. The thin filaments are composed of the protein actin, which are anchored to the Z lines on the outer edges of the sarcomere. Because the actin filaments are anchored to the Z lines, the sarcomere shortens from both sides when actin filaments slide along the myosin filaments. Although the action between the filaments is described as sliding, the myosin filament actually pulls the actin along its length. The cross bridges of the myosin filaments attach to the actin filaments and exert force on them to move. This action is known as the sliding filament mechanism of muscle contraction. In this model, the sarcomeres shorten without the thick or thin filaments changing in length. A contraction begins when a bound ATP is hydrolyzed to ADP and inorganic phosphate. This causes the myosin head to extend and can attach to a binding site on actin, forming a cross bridge. An action called the power stroke is triggered, allowing myosin to pull the actin filament toward the M line, thereby shortening the sarcomere. ADP and inorganic phosphate are released during the power stroke. The myosin remains attached to actin until a new molecule of ATP binds, freeing the myosin to either go through another cycle of binding and more contraction, or remain unattached to allow the muscle to relax.
All right. So hopefully you guys don't feel overwhelmed from that, but that's more information than you need, like with the various stages. There's 5 to 7 stages, again, depending on who you ask. Starting with motor nerve impulse and ending with and then going to contraction and then ending in relaxation or recontraction. So let's just review the terms one more time. So this is a sarcomere, and there's a Z disc on either side, and that sections off one sarcomere from another. So there's half of a sarcomere here, there's a full sarcomere pictured, and another half pictured here. And attached to the Z disc are the thinner actin filaments, and they are overlapping or adjacent to or between the myosin filaments. And the myosin filaments, they pull the actin filaments towards each other, and the actin filaments slide past the myosin filaments, and that pulls the Z discs, or the ends of the sarcomere, pulls the Z discs towards each other, pulls the two ends towards each other. If we look at it here, we don't see, I mean, in a way, this drawing is kind of cool because it makes the Z disc and the actin filament look really integrated, and it makes the myosin filament look very separate from the actin filaments. So you kind of get that these myosin filaments are very solid and thick and are not going anywhere, and that these thinner actin filaments will be pulled along the length of the myosin fibers. Do you guys have any questions about sliding filament theory? I think that's enough information for sliding filament, and so I'm going to stop there. If you feel confused, I'd like you to unmute and ask for clarification. And just like you guys always do, you just call out and say, I don't really understand this thing that's happening here. Okay, if you guys are sure that you're good, we'll move on. And we can always come back to it, okay? The next is the type of contractions, concentric, eccentric, and isometric. Before we do that, let's go to our review document. And let's look at, that's MBLEx March 2023 basics. And let's go down to the muscle section. And I just want you guys to review this here, which is that a whole muscle is made up of many smaller bundles known as fascicles. So a muscle is made of fascicles. Each fascicle is made up of muscle cells or myofibrils. So fascicles are made up of myofibrils. Fibers, made up of myofibers. Myofibers contain myofibrils, which contain myofilaments. And the myofilaments are made up of actin and myosin. So the myofilaments actually make up the sarcomere. So that would look like this. So every muscle is made up of fascicles, and every fascicle is made up of myofibers, and every myofiber is made of myofibrils. And if you look at the myofibril down here, if you look at the myofibril, you can see that there are many filaments, that there are myofilaments, and the myofilaments are actin myofilaments or actin filaments, and then myosin myofilaments or myosin filaments. Yeah. Muscle, fascicles, myofibers, myofibrils, myofilaments, actin, and myosin. All right, next one. Understand the differences between the types of contraction, like concentric, eccentric, and isometric. I just put some like good old-fashioned boring words on this slide because I want you guys to be able to speak, like to say what isometric, concentric, and eccentric are. Right? It's really important. Oh, I should add isotonic. So let me get you a definition for isotonic. Definition of isotonic. See, they didn't put that on the FSMTV e-guide, but I've seen it on the test prep questions. Isotonic contraction. So tension remains the same while the muscle's length changes. That's pretty lousy. Tension remains the same while the muscle's length changes. So I'm going to put in keeping, so I can make it similar with the others. I'm going to say that isotonic is where a muscle tension remains the same while the muscle's length changes. Tension remains the same, muscle's length changes. The speed remains constant. They're not going to ask you the difference between isokinetic and isotonic. I'm just gambling on that. Isotonic, a muscle changes length, which is eccentric. While the resistance stays the same, and that's the tonic. Tonic means the resistance stays the same. So this is a really the resistance stays the same is a really counterintuitive thing to say. So if you pick up a bag, if you pick up 30 pounds of groceries or 8-pound gallon of water, or your niece or nephew who's, you know, a very butterballish 40 pounds, or your 50-pound dog or whatever, and you pick the child or the groceries or the dog or the gallon of water up, the contraction as the muscles change shape is an isotonic contraction. Some muscles are contracting concentrically and some muscles will contract eccentrically. Isotonic just means that the muscle is contracting. It can be eccentric or concentric. It also means the resistance stays the same, so that 50-pound dog does not gain or lose weight as it leaves the ground. It stays 50 pounds throughout the entire movement process. Also, the resistance does not change. So the rate at which you are moving it, or the force required to move it, does not change. So sometimes we put we put things like resistance bands or chains or other things on weights or on our bodies, and as you pick the weight up or you pull the band, it gets tighter and tighter and tighter. The resistance gets higher and higher and higher as you pull the band, and as you let the band go, the band relaxes and the resistance gets lower and lower and lower and lower. So technically, that's a different amount of resistance through the arc of the movement. So that would not be isotonic. That would not be tonic. So anyhow, isometric. Isometric is where the muscle contracts, but there's no motion. No motion anywhere. No motion in the bones, no motion in the joints, no motion in the muscles. So there's no change in the muscle length. There's no change in the joint angle, and there's no change in the movement of the bones. Dora.
Yes.
Hi, Dora.
Hi.
Can you give me an example in the shoulder, of one of the muscles which we frequently do as an isometric?
Let's see.
For the purposes of activating or warming up or rehabbing a muscle, or warming up or activating or rehabbing the shoulder joint. Okay, it's the muscle that does external rotation through the shoulder, Dora. So this motion here is external rotation. See, the humerus is going out that way. So do you remember what muscle that is? It does external rotation.
Is it the bicep? No, it's
The bicep does.
yes.
It's in the back of the shoulder. It's on the scapula, and it's inferior to the spine of the scapula. Inferior to the spine of the scapula. It's the infra. Inferior to the spine of the scapula. Infra.
Scapular.
I love how you're thinking. Infraspinatus.
Spine. Yes.
Infraspinatus. That muscle is frequently used for isometric work, where someone has a shoulder injury and they'll put the back of the hand or the back of the arm or the back of the wrist against a wall, and they'll have the person externally rotate into the wall. At this point, the infraspinatus muscle is contracting. Everybody do this. Infraspinatus muscle is contracting, but the muscle is not changing length. And the joint is not moving. There's no movement in the joint. The bones are not moving around. So that's a very good way to activate the muscle in someone who has an acute injury, because you don't have to change the angle of the joint and the muscle doesn't have to shorten and lengthen. So it reduces the chance that the muscle or the joint will be irritated, or that structures around it will be irritated. So that's why isometrics are really, really important for massage therapists and all therapists. Also, when you reach the bottom or the top of a movement, for example, when you squat all the way down for just like half a second while you're down there before you come back up, you're holding that position and everything is contracting. That's isometric. When you push all the way up to the top of a push-up for a second, just a split second before you lower back down, that's an isometric. Same with the bottom. The bottom where you hold the position of the push-up is an isometric. So when you reach the end of the range of motion before you come back, there's a split second isometric there. Now, concentric is a muscle contraction with shortening. Dora, can you mute, please?
Yes.
So concentric is a muscle contraction with shortening, and that's where it overcomes the resistance. So Stephanie, so if a concentric contraction overcomes resistance, where in the push-up do we see concentric contraction of the pecs and the triceps? Is it when the person pushes up from the floor, or when they lower down to the floor?
When they lower down to the floor.
Think again. Okay, the definition is a muscle contracting with shortening, shortening of the fibers, and it overcomes resistance. So the resistance in this case is gravity pulling the weight of the body down. It's gravity, right? So that's the resistance.
Okay.
So how do you overcome the resistance of gravity pulling the body down? Do you go down or do you go up?
You go up.
You go up. That's right. And how about in a squat? Same thing with a squat. How about in a squat? Is overcoming the resistance going down with gravity or going up away from gravity?
Going up.
That's right. And how about with a bicep curl? So a bicep curl looks like this.
Yes.
So which way is the concentric? Which way am I overcoming resistance? Through flexion or through extension of the bicep?
Flexion.
That's right. Correct. Good. I think you got it. Awesome. And you can mute, please. And Vincent.
Yes.
Hello, Vincent.
Hello.
So concentric, eccentric, isometric. Eccentric is where the muscle lengthens. The muscle lengthens. And that's where the resistance or the weight or gravity overcomes the muscle. So in a squat, the concentric contraction overcomes gravity by going up, by pushing the weight up through space. where is the eccentric contraction in the squat? When the body goes down, when it holds at the bottom, or when it goes up?
Well, down and you hold.
When it goes down, yes, the hold, no, not the hold. The hold would be isometric, right? Because there's no movement at any point of holding, whether it's the bottom or the top. So when you stand up through the squat, at the top, there's a split second of isometric before you eccentrically lower down. And when you eccentrically lower down to the bottom and you get to the lowest point of the squat, there's a split second of isometric at the bottom before you concentrically come back up. All right, and now where's the eccentric? Tell me where the eccentric contraction is in a push-up.
Down after you get down.
When you lower yourself down. That's right, that's right. Okay, now the flexors, I want to know about the flexors and the extensors of the neck. Ignore the sideways, the side flexion. I want to know about the flexors and the extensors of the neck. So if you flex your neck, dropping the chin to the chest, if you flex your neck, where is the eccentric contraction?
Oh. When you flexing?
When you flex your neck,
Yes.
I'm not sure if you got the question. When you flex your neck, where is the eccentric contraction? In the flexors or in the extensors?
The extensions.
Yeah, I was trying not to say flexors and extensors.
Yeah,
I
sorry.
wanted you to say that. Yeah, that's okay. And then if you extend the neck, where's the eccentric contraction?
In the flex, no, in the
In
extent.
the
Yeah, flexors.
In the flexors. That's right. That's right. Okay. Thank you, Vincent. Please mute yourself. Is everybody clear on isometric, concentric, and eccentric, and isotonic? Does anybody want to go over that again? Okay, great. Take a look at these on a regular basis. Take a look at the light, especially like the second part of it, where it talks about resistance, right? You need to understand that going back down in a squat or a push-up is resistance overcoming the muscle. And then pushing away from the ground in a push-up or a squat is overcoming the resistance, the muscle overcoming the resistance. But I bet dollars to dimes that they'll ask you about isometric, contraction without motion, no change in muscle length, joint angle, or movement of bones, that being relatively safe for acute injuries. Okay, onward. So now we're going to get into some of the agonist, antagonist, synergist, and prime mover, and then we're going to go through some questions from the FSMTB practice test. So when you do, okay, so first of all, we're talking about neck flexion and neck extension, right? So here's a kind of an abstract drawing, because this is a drawing of it's the muscles of the neck and the skeleton after all the top layers have been removed, right? So you're just seeing the muscles, and you're seeing superficial muscles like the sternocleidomastoid muscle, and then the scalene muscles, and you're seeing some of the deeper muscles, and these are the ones that I really want to show you. Those are the longest colli, and the longest capitis. Where's the longest capitis? Oh, here it is. This is the longest capitis. Right here. Right here is the longest capitis. And then this is the longest colli, So the longest capitis and the longest colli we haven't talked about yet. I'll just introduce them to you now. So if you lower the chin, if you flex the cervical spine, the longest capitis and the longest colli are contracting bilaterally. If you turn the head, the turning side longest colli and longest capitis is contracting, but not the other side. So if I turn my head to the left, my left longest capitis and longest colli are contracting. If I turn my head to the right longest capitis and longest colli are contracting. And the opposite is true for the sternocleidomastoid muscle. If I turn to the right, my left SCM is contracting. If I turn to the left, my right SCM is contracting. So I want you guys to be the people in the test who are going like this, who are doing the movements and maybe palpating your neck and trying to feel. You can't feel the longest coli and the longest capitis unless you really press past the trachea and past the SCM, which I don't recommend you do that in the test. But just imagine they're on one side, so if they're shortening, they're probably going to be pulling toward that side in rotation. And if they're contracting bilaterally, you'll be lowering them down. So when we talk about neck flexion, lowering the chin down, I want you to think about the flexors of the neck, and the main flexors, like the agonists, the prime movers for that, are the sternocleidomastoids, the scalenes, the longest capitis, and the longest coli. Longest capitis and the longest coli. You can remember capitis like head. It attaches to the skull. It attaches to the very bottom of the skull. And then you can remember coli. Let's see, I think that means collar. Let's see if I got that breakdown of longest coli, word breakdown. Remember, if you want to know what anything means, you type in the word, the name of the muscle in this case, and then word breakdown. Longest coli, long muscle of the neck is known as the longus cervicis, since it spans the entire cervical spine and the first 3 thoracic vertebrae. By acting on the cervical vertebra, the longus coli is responsible for forward and lateral flexion and rotation of the neck. Longus coli, Latin for long muscle of the neck. So coli must mean neck. Coli must mean neck. All right. Again, it's the longest coli, the longest capitis, also the SCM muscle, and then the scalenes, the scalene muscles. That's for flexion. So if you're lowering, so if the question is in neck flexion, which muscles are contracting concentrically? Or, these 4 muscles contract which way, concentrically or eccentrically? Or what are these 4 muscles? Are they the agonist, the antagonist, or the prime mover? So Mint. Mint.
Hello. Yeah. Yes.
Hello, Mint. So in neck flexion, are these 4 muscles here, the sternocleidomastoid, the scalenes, the longest capitis, and coli, are they the agonist, or are they the antagonist, or the synergist? In neck flexion. Mint, do you know what neck
Longest.
flexion looks like?
Mm,
Mint, do you know what neck flexion looks like? Can you see me? It looks like this.
yes.
Okay, that's neck flexion. And then would you say that the muscles that we named in the front, the sternocleidomastoid, the scalenes, the longest capitis, and the longest coli, would you say that these muscles are agonists in flexion, or antagonists, or synergists?
Antagonist.
Agonists, because they're doing most of the work. See, neck flexion is moving in the direction of the fibers. All the fibers are going this way, right? So the fibers are shortening. That's a concentric contraction of an agonist muscle. And then Mint, where would the antagonist muscle be? Front, side, or back of the neck?
On the sides.
On the back of the neck. Back of the neck. Because as you lower the chin down and flex the neck, the back of the neck is opening or lengthening. Those muscles are lengthening, and the muscles in the front, the flexors, are shortening. So the eccentric contraction would be in the back of the neck. The antagonist is in the back of the neck, contracting eccentrically. And then which one is the prime mover, Mint? Is it the muscles in the front or the muscles in the back?
In the palm mover.
The prime mover, yes. If you're flexing the neck, is the prime mover in the front or the prime mover in the back?
In the back.
No.
Oh, in the
The
front.
prime mover is, yes, the prime mover is always which one? The agonist
In the
or the
front?
antagonist? Yes, in the front. Yes. And the prime mover is always which one meant? The antagonist or the agonist?
And antagonist. I don't know.
No, it's okay. It's okay. Hey, is anyone else confused about which group or which muscles are antagonist, agonist, synergist, and prime mover? Do we need to review those with a few common movements?
No.
No, I'm good.
Yeah, I think
No.
we're good.
Okay. All right. Well, let me just work into the following movements then. Let me just work into the following movements, which are agonist, antagonist, synergist, and prime mover. And we'll, I mean, that is the next learning, that is the learning objective we're on anyway. So I guess we'll just do like the couple additional movements that I had planned, and then we'll move on from agonist, antagonist, synergist, and prime mover. But please review those. Okay, so if you squat down, there's 3 joints involved. There's the hip joint, the knee joint, and the ankle joint. So I want to explore which muscles are agonist when you squat down and which muscles are antagonist. Remember, the agonist will be contracting concentrically, the antagonist will be contracting eccentrically. The agonist will be contracting concentrically, the antagonist will be contracting eccentrically. All right. So as you're squatting down, what's happening in the around the hip? You have the hip flexors in the front. Everybody unmute. You have the hip flexors in the front. Are the hip flexors shortening or lengthening in the front as you squat down?
Lengthening.
Look at the drawing or yourself. Stand up and squat. As you squat down, are the hip flexors lengthening or shortening?
Shortening.
Okay, yeah, they are.
Yes, good. It's good, fine to make a mistake as long as you learn. Yes, so they are shortening. And if they're shortening, would that mean that they're contracting eccentrically or concentrically?
Concentrically.
Concentrically, that's right. And would they therefore be an agonist or an antagonist?
Agonist.
An agonist, that's right. How about the other side of the hip joint? The gluteus maximus muscle. Is the gluteus maximus muscle, as you squat downward, are the fibers lengthening or are they shortening?
Lengthening.
That's right. So is that concentric or eccentric?
Eccentric.
Eccentric.
Eccentric, that's right. And would that be the agonist or the antagonist?
Antagonist.
Antagonist, that's right. Okay, now continuing through let's go from the hip joint to the knee. Okay, so the knee is flexing as you squat down. The knee goes into deep flexion. And what's happening to the quads? Are the quads lengthening or shortening?
Lengthening.
Yes, very good. And does that mean that they are concentric contraction? Does that mean that they're contracting concentrically or eccentrically?
Yeah.
Concentric, eccentrically, yes. And what about the hamstrings? Are the hamstrings, as the knee flexes, shortening or lengthening?
Shortening.
Shortening.
That's right. Mint, unmute and practice with us. So if the hamstrings are shortening, are they contracting concentrically or eccentrically?
Eccentrically.
If they're shortening, are they concentric or eccentric? Concentric, right. Con, like with the direction of the muscle fibers, like con, like shortening. Eccentric away, like lengthening. Eccentric lengthens, concentric shortens. Okay, and now the ankle, as you start to, this one's a little bit, you might not be familiar with this because a lot of people don't think about this. So the tibia starts here. The tibia starts here on this gray line. when the squatter is standing up. Now, as the squatter starts to move down, the tibia starts to shift and point forward at this angle. So tell me something, what is happening at the ankle? Is that plantar flexion or dorsiflexion?
Dorsey.
Dorsiflexion, nice. Dorsiflexion, mint. And so, and thank you for participating. And then, so if there's dorsiflexion happening as you squat down, what's happening in the tibialis anterior muscle? Is it shortening or lengthening?
Shortening.
Does everyone agree?
Lengthening.
Oh, no. So everybody stand up, right? And I want you to, sorry if I'm making a lot of noise. And I want you to look down at your feet, and I want you to do a squat. And can you feel your shin muscle contracting? And can you see how the foot is moving into dorsiflexion?
Yes.
Right? As I squat down, my foot is going like this, right?
Yes.
Like that. So is the tibialis anterior contracting eccentrically or concentrically with that dorsiflexion?
Eccentrically.
Look at your foot again. Look at your foot again.
That's what I thought it was, because it goes up. Yeah, your ankle.
Well, yes, the foot may be going up, Vincent, but the weight is going down.
Oh, okay.
So
Okay.
gravity is overcoming, and thinking about that is thinking about the movement overall. That's called the eccentric phase of the squat. But if we break the squat down into agonist and antagonist around the hip, agonist and antagonist around the knee, agonist and antagonist around the ankle, we get one eccentric and one concentric, and that's what we're trying to decide.
So it should be
So-
eccentric.
It should be concentric, brother. I don't mean to misgender you. I'm assuming,
You good?
but it should be concentric. It should be concentric. All right. So you guys, last time for the team, we got to get this right now. Okay, we got to get this right. All right. So dorsiflexion, which brings the toes up, which changes the angle so that the toes are coming up, or so that the knee is going forward from the toes. The tibia is going forward of the toes. Dorsiflexion. Are the fibers of the tibialis anterior muscle, the shin muscle, are they shortening or lengthening?
Shortening.
Shortening. What do you think, Vincent?
Yeah.
Okay, great. And then does that make them concentric or eccentric, Mint? When fibers shorten, is that concentric or eccentric, Mint?
Concentric.
Concentric, not eccentric. That's correct. And Stephanie,
Yes.
as you squat down and the ankle moves into dorsiflexion and the tibia moves forward of the ankle, what is happening in the posterior compartment, in the gastrocs and the soleus? What's happening back there?
It's lengthening.
Yes, which makes it what kind of contraction and what role?
Eccentric.
Very good. And does that mean it's an agonist or an antagonist?
Agonist.
Antagonist. There you go. Antagonist. What's the difference between an agonist and an antagonist?
Agonist is the one that helps or goes against. No,
No, agonist is the prime mover.
the prime mover.
It does most of the work. The antagonist opposes the agonist.
That's what I meant. More the word. So the synergist is the one that helps.
The synergist is the helper muscle, right? So like the peroneals on the side of the leg might be a synergist for the ankle, might be a synergist for the tibialis anterior, or for the gastrocs. And remember that the agonist does what kind of contraction? Isometric, concentric or eccentric? I'm sorry. Agonist does what? Concentric or eccentric?
Concentric.
Concentric always. And the antagonist does what kind of contraction? Eccentric. Yeah. All right. So now, should we go the other way in a squat? I'm hearing people go like, I'm hearing you guys are almost moaning now. Okay. So let's take a break, come back in 10 minutes, come back at 9:13, and we will resume the torture. I mean, the lesson. We'll resume the lesson. All right. So everybody unmute. So let's take a group. Let's take like muscle pair by pair. We did the whole lowering eccentric phase. And now we're going to do the whole, I was going to do the whole concentric standing up phase of the squat, like overcoming gravity. Remember that a concentric contraction is where you overcome resistance or you overcome gravity, and an eccentric is where the resistance or the gravity overcomes the muscle. So, but I think we better break it down into pairs, antagonist and agonist pairs, and then do both movements, the lowering and the up phase. So the hip flexors, they shorten when you lower down into a squat. We established that. When you push away from the ground and you stand up, can you guys see that the hip flexors are lengthening? And can you tell me what is happening in the glutes as you stand up from a squat? Are the glutes shortening or lengthening?
Shortening.
They are shortening. So which is the agonist and which is the antagonist, Stephanie? The hip flexor or the glute when you're standing up? Agonist is the prime mover that shortens. Antagonist is the eccentric that lengthens.
So the glutes is the antagonist.
No, the one that shortens is the agonist, concentric agonist, prime mover. So can you give me those two one more time? Which one is the agonist? Which one is the antagonist?
The agonist is the glutes.
Yes.
The prime mover,
Yes.
right? Shortening.
Yes. Yes.
Hip flexors is. See, I get confused. I just said it.
Yes, you did. There you go. Good. Yes, perfect. You did it exactly as you should have for someone who's confused. You're like, oh, I just said, what did I say? I said agonist. So the hip flexor must be the antagonist. That's exactly how you do it. Exactly how you do it. Yes, antagonist. Very good. So now, Stephanie, who's almost off the hook, now when you lower down into a squat, now which one is the agonist? Which one is the antagonist? The hip flexor, the glute?
The hip flexor is the agonist because it's shortening.
Very good. Very good.
Prime glutes.
And the glutes are what? The antagonist. That's right. That's right. Good, 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 good. Okay, everybody else unmute. So far, this is like the Kim Sue Stephanie class. So Mint and Dora, you guys unmute so you can participate. So now let's look at the quads and the hamstrings. These are the pairs, the quads and the hamstrings. So pushing off, standing up. If you're standing up, which one is shortening? Which one is shortening? Look at the movement of the knee, the movement of the femur against the knee. Which one is shortening as you stand up?
The quads.
The quads or the hamstring. That's correct. And that must mean the hamstring is what? Lengthening or shortening?
Lengthening.
That's correct. So so can you name which contraction is which in the quads and the hamstring? Eccentric or
Yes.
concentric?
Standing up wise, it will be your quads are agonist,
Yes,
and your hamstrings is antagonist.
very good.
Standing up.
And where is the concentric and where is the eccentric?
Concentric is in your quads, standing up, and
Good.
the eccentric is in your hamstrings.
Very good. And where's the isotonic? When does that happen? Where's the isometric? Where's the isometric happen?
Your hamstrings.
Remember, an isometric contraction is what happens when the muscle contracts with
Yeah.
no movement. With no
Yes.
movement.
Well, you're
So
completely
where does that-
standing up. When you're
That's right.
completely
When you
standing up.
completely, yes, AKA lockout. When you stand all the way up, or when you squat all the way down at the bottom. It's always at the apex or the end of the movement that you have a split second of an isometric. Metric means measurement. So measurement doesn't change, length doesn't change. Okay. I thought we were going to do this like, all at once as a class, but you guys are like muting and unmuting. So I'm just going to have to call on you. So let's see who's next. Dora.
Yeah, I've been on mute.
Hello. So you have we did the hamstring and the glute as a pair. No, we did the hip flexor and the glute as a pair. Then we did the quad and the hamstring as a pair. Now we're going to do the tibialis anterior and the gastrocs as a pair. So when you stand up, what happens in the tibialis anterior, or what happens in the quad, or what happens in the gastroc, the tibialis anterior and the gastroc? This is a hard one.
The tibialis anterior extends. Is it? I'm not sure.
I think you are on the right track. Start with lengthening or shortening.
Lengthening.
Lengthens or shortens?
It
Yes,
lengthens.
very
And
good, Dora.
The opposite of that would be shortening it.
Yes,
In the back.
and those are,
The
yes, which muscles are in the back?
I always forget.
Gastrocs.
Gastrocs.
That's right. Yes, the gastrocs. Yes, the gastrocs. And which one is the prime mover then?
The prime mover would be the gastrocs.
Very good. Is that an eccentric or a concentric contraction in the gastroc?
It would be concentric.
Very good. Very good. And where's the eccentric?
In the tibialis anterior.
Okay. And for the tibialis anterior and the gastroc, what joint are they primarily moving? The knee or the ankle?
It would be the knee, I would say. Or if they're doing the flexion,
think
it
about
would be
in either of the movements, but think about where the muscle bellies are, and think about the joints that they cross. Think about like which bone is more stable. They're attaching to the tibia bone, which is more stable, and then they're crossing the ankle joint. The tibialis anterior doesn't cross the knee joint.
Oh,
The gastrocs, I think, do cross the knee joint.
So it would be the ankle.
The ankle, that's right. That's correct. That's correct. Mint.
Yes.
What is the definition? What is the definition of isometric? Isometric. Is that where the muscle shortens, or where the muscle lengthens, or is it where the muscle stays the same length, doesn't change?
I still confused for this. I
Okay.
still not get it.
Okay. Okay, perfect. So con means what? Shortening or lengthening? Concentric. Con.
Shorting,
Very good. Very good. And E, like eccentric. E means what? Shortening or lengthening?
lengthen,
Lengthen. That's very good. And then so ISO, what do you think ISO means? Shorten, lengthen, or stays the same?
Stay the same.
That's right. Like isolating, right? Like isolated, stays the same. And then metric, the word metric. What do you think of when you hear the word metric?
Concentric.
Think about metric. Metric. The word metric. What comes to mind when you hear metric?
Longer. Gonna be
Long, yeah, length, or metric as a way of measuring, right? So
Yeah.
metric as in like meter, centimeter, millimeter, metric versus what's the other one called? I think imperial, where you use like inches, feet, right? So
Yeah.
two different ways of measuring length. So ISO, isolated, staying the same. Metric,
eccentric.
a way of measuring. No. Isometric. Isometric is the opposite of eccentric and concentric. So can you see the slide here? Can you see the words on the slide? Am I sharing
Yeah.
my screen? Okay. So isometric is the opposite of eccentric and concentric. With ISO, there is no movement, right? And with
Yeah.
metric, there is same length, right? Or just length. So no movement in the length, no change in the length, isometric. With concentric, you have shortening. With E, like EC, ek, or E, it means away, so lengthening, the two ends of the muscle going away. So eccentric, lengthening, concentric, shortening. Isometric, no movement in the length, no change in the length. Okay, now you tell me, last time, okay? Tell me, what does isometric mean? Shortening, lengthening, or no movement in the length?
No movement.
Very good. And what does concentric mean? Shortening or lengthening?
Shortening
Very
Short-
good. And eccentric?
is lengthening.
Very good, Mint. Very good, Mint. You're 85% of the way there. Very good. Very good. Okay. Ooh, yeah. Come on. All right. Now we got a difficult one here. Okay. Let's see. All right. Who can I give the difficult one to? How about Vincent? So Vincent, in the push-up. Now the arrows are a little confusing. They go this way, they go clockwise. Okay.
Okay.
Go like this. All right. So tell me why this says concentric from here to here. Why does it say concentric?
Oh, because you short. Well, I don't know. Interesting.
Yes, I agree. Why is it? What you said shortening. What is shortening? When you do a push-up, what muscles do you work?
Your biceps and triceps.
Biceps and triceps. On this planet, gravity goes downward.
Yes.
So if you're pushing into the floor, it's not
Yes.
your biceps that are working.
Yeah,
It's your pectoralis muscles. It's your triceps. It's your triceps for the elbow extension. Yes. It's also your pecs.
Yes.
And to a lesser extent, the anterior shoulder muscles, the delts.
Yes.
Anterior delts. So why does this say concentric, going from a low plank to a push-up, pushing away from the floor? Why is that concentric?
You're fighting gravity. You fighting gravity.
Because you fight in gravity. And are you overcoming gravity, or is gravity overcoming the muscle?
Overcoming gravity.
That's correct. And what's happening to the length of the muscles?
They get they lengthening.
They're shortening.
Yes.
They're shortening, which makes it what kind of contraction? Concentric or eccentric?
Contraction. Contraction.
And what must? And you got the con. That's good enough. And what muscles are involved? Name at least two.
Your pectoralis and your triceps.
Yes, very good. Okay, and now lowering down toward the floor. Let's see, which one is that? That's this one here.
Yes.
Okay, top right to bottom right. Top right to bottom right. What's happening there?
Your eccentric
Contraction in which muscles?
your biceps and your
Going from pushing to lowering down, getting ready for a push. That's the pec. The pec.
Yes.
Yes. No bicep. No bicep. Pec and tricep. Pec and tricep.
Okay.
The tricep and pec are used for pushing. The bicep is used for pulling. So the bicep would be used for used for rowing, or it would be used for pull-ups or chin-ups. Okay, this is a push. It's a push. So it's the tricep and the pec. All right, and what's happening with the relationship between gravity, or the relationship between force and the muscle? Is the force overcoming? No, I'm not saying this right. I'm sorry. Let me get my terminology straight. Is the resistance overcoming the muscle, or is the muscle overcoming the resistance?
The resistance overcoming the muscle.
That's correct. That's correct, which is how you end up closer to the ground. Okay, very good, guys. Very good. Let's point out a couple other things. Ooh, it's difficult, isn't it? It's like a lot of repetition, yeah? But the more you repeat, the easier the more familiar it will become. So we just went over these muscles in the front of the neck. These are the neck flexors. And in the back of the neck, we have the neck extensors. So we have 4 flexors in the front: sternocleidomastoid, scalenes, longus capitis, longus coli. And we have 4 muscles in the back: upper trapezius, levator scapula, splenius capitis, splenius cervicis. Now I know that you know where the upper trap and the levator scapula are located, but so I didn't include pictures of those, but I did include pictures of the splenius muscles, splenius cervicis and splenius capitis. Mint.
Okay.
Yes. Which one do you think is the splenius cervicis, and which one do you think is the splenius capitis? Okay, what do you think? What do you think cervicis? Can you see my cursor? I'm highlighting cervicis. What do you think of when you hear cervicis? Maybe you think of cervical spine, like cervical vertebrae. Does that make sense to you?
Yeah.
Yes. And when you hear capitis, when you hear cap, what do you think of? Cap. Cap, like a cap you put on your head, or like da capo in music, to the top, or el capo, the captain. You should think of the head, capitis, capitis.
Okay.
So which one is splenius capitis? The one that attaches to the head, or the one that attaches to the cervicals?
On the head.
That's right. And which one is splenius cervicis? The one that attaches to the cervicals, or the one that attaches to the head? Splenius cervicis, Mint. Which
And
one?
the first
one that
one?
attached.
But
Which one is the first one? Does the splenius cervicis attach to this? Go ahead.
the The tab.
The cervicals, Mint. The cervicals. You did good, Mint. You thought very hard about it, and that's fine. You learn how? By making mistakes and repeating, Speaking of repeating, Mint, where does the splenius cervicis attach? The cervical spine or the head?
On the spine.
Very good. Can I hear you say cervical spine?
Cervical spine.
Thank you very much. Thank you very much. And where's the splenius capitis attach?
Spine is certified. I don't. Is
Capitis. Where does the
hard to pronounce.
capitis attach? Yes, it is difficult to pronounce.
It's hard to pronounce for me.
Yes, it's okay. Splenius capitis attaches where? To the head or the cervicals?
And the head.
On the head. Very good, very good. What does splenius mean, Mint? Splenius, what does that mean? I didn't tell you
Spine.
yet. It means, no, splenius, I didn't tell you yet. Splenius means flat. So these are the flat muscles that attach to the cervical spine, the splenius cervicis, and the flat muscles that attach to the head, the splenius capitis. So the muscles in the back for neck extension are the upper traps, the levator scapula, the splenius capitis, and the splenius cervicis, or you can say the spleni muscles, right? And now how about, I think that's about enough. I think that's about enough of the, like the hardcore muscle stuff. That was rough, wasn't it? Wasn't it, ladies and gents? That was rough. Okay,
It's
so
hard to
let's
do.
move on. Yeah, well, we're getting into it. Yeah, you know, I mean, I want to say, I don't think you guys are practicing quite enough. I say that, I'm sorry. I don't think you guys are
Yeah.
studying quite frequently enough. You guys are showing up and like kind of not knowing this stuff, and you know that's not going to get you there. FSMTB MBLEx sample exam, new document. Thanks to my son who helped me to copy and paste all this stuff. Should have heard him complaining. Not like I didn't pay him for it. Okay, what term is synonymous with the prime mover? Everybody unmute and call out. What term is synonymous with the prime mover? Ignore the colors. Is it the fixator, the antagonist, the synergist, or the agonist? Which is synonymous with the prime mover? The agonist, that's right. Syn means same as, same, like syndesmotic or synarthrosis, amphiarthrosis, diarthrosis. Synarthrosis means two bones that become the same, right? Synonymous with prime mover is the agonist. I'm looking up the word synergist. I'm taking a look here, okay? The second one, the reciprocal inhibition process. Let me make this a little larger. No. Yeah. The reciprocal inhibition process occurs when a agonist muscle is in action and the antagonist muscle becomes inhibited. Synergist muscle is in action and the agonist muscle becomes inhibited. Antagonist muscle is in action and the synergist becomes inhibited. The fixator muscle is in action and the antagonist becomes inhibited. Which one?
A.
When the agonist muscle, can you read this for me, Mint?
Agonist muscle is in action.
Good.
And the agonist must become
antagonist.
antagonist.
Yes. Becomes what?
I don't know.
Inhibited.
Inhibited.
Very good. Inhibited. When you inhibit something, you stop it.
Inhibited.
Inhibited, very good, very good. Inhibited. Inhibited is the opposite of activated. The agonist becomes activated, the antagonist becomes inhibited. Reciprocal, that's okay. The
My
agonist
English-
becomes,
Second language is
yes,
hard to understand.
yes, I know,
Yes.
and
I'm from
I'm
Thailand.
trying, yes, and I'm trying to help you with that.
Thank
So, yes, of course, by repeating is good. The agonist is becomes activated and the antagonist becomes inhibited in reciprocal inhibition. Mint. Do you remember which sensory organ does reciprocal inhibition? Is it the Golgi tendon organ or the muscle spindle intrafusal fibers?
The first one. What is it?
Which one does reciprocal inhibition? Is it the Golgi tendon organ or is it the intrafusal muscle spindle fibers? It's the intrafusal muscle spindle fibers. Intrafusal muscle spindle fibers. You could go to your March 2023 basics and put in reciprocal, or you can put in intrafusal, and it's right here. Which does reciprocal inhibition? Which does agonist inhibition? Oh, actually, it doesn't tell you here, does it? Yeah, it doesn't tell you. I'll put it down for you. Which does reciprocal inhibition? That's intrafusal fibers. And which does antagonist inhibition, agonist? This doesn't make any sense. Oh, antagonist inhibition versus agonist inhibition. That would be antagonist inhibition is the same as reciprocal. So that's intrafusal fibers versus agonist inhibition, which is the Golgi tendon organ. All right, you guys make sure you review this. Which does agonist activation, there's that word meant, agonist activation versus antagonist activation. Agonist activation would be intrafusal fibers versus antagonist activation, which would be the Golgi tendon organ. When you have agonist inhibition, that's the Golgi tendon organ. You pick up something very heavy, the load is too heavy, the Golgi tendon organ says, let the agonist go, let the weight go, inhibit the agonist. When you start to move something too quickly, or the muscle stretches too quickly, the intrafusal fibers say, contract the agonist faster to keep it from overstretching. So lifting too heavy forces the agonist to inhibits the agonist. That's the Golgi tendon organ. Stretching too quickly or too much causes the agonist to contract and inhibits the antagonist. That's reciprocal inhibition. That's the intrafusal fibers. That is in this document here. Muscular, if you go to muscular, you'll find all that information about intrafusal fibers and Golgi tendon organs and reciprocal inhibition and activation. You'll find it all there. And you can always ask me.
Thank you.
Okay. You're welcome. You're welcome. That was for everyone. Okay, next. Is it? It's twice. This is twice in the same question. Yes. Okay. Okay. Which muscle acts as a synergist with peroneus longus during eversion of the foot? Which muscle acts as a synergist with peroneus longus during eversion of the foot? Now, this is difficult because we didn't go over all of these muscles, to be honest. Posterior, we didn't talk about extensor digitorum longus, extensor hallucis longus, we didn't talk about. So which do you guys think is the synergist with peroneus longus during eversion? Eversion is picking up the pinky side, picking up the outside, the lateral edge of the foot. That's primarily the job of the peroneus group, peroneus longus, peroneus tertius, peroneus, brevis, peroneus tertius. Which one do you think helps? Which one do you think is a synergist for the peroneus muscle? Is it the tibialis anterior, the tibialis posterior, the extensor digitorum longus, or the extensor hallucis longus?
Tibialis posterior.
Unfortunately, it's the extensor digitorum longus. So picking up the outer edge of the foot is done by the extensor digitorum longus, but plantar flexing the foot would be the tibialis posterior. Dorsiflexing would be the tibialis anterior. Okay, now let's take a look at no concentric. Okay. Oh, okay. No concentric. Okay, what about eccentric? No, no eccentric. How about what else did we cover tonight? Agonist, antagonist. Okay. Which muscle acts as an antagonist to the gastrocnemius during plantar flexion? During plantar flexion, which muscle acts as the antagonist to the gastrocnemius? Is that the tibialis anterior, the peroneus brevis, the soleus, or the plantaris?
The soleus?
Which muscle, if in your mind's eye, which muscle opposes the gastrocs?
Is it tibialis anterior?
Tibialis anterior, that's right. Stephanie.
Yes.
Picture the tibia, okay? Picture the tibia bone. Which side of the tibia is the gastroc on? The front or the back of the tibia?
The front?
The gastroc?
No, so it's in the back.
It's the back, yes, yes. Like if you imagine looking at someone from the back and you're seeing their hamstring and you're seeing their heel, and then you're seeing these muscle bellies on the lower leg, and those are the gastrocs. Are you oriented now?
Yes.
Okay, and then where is the soleus? Is it on the front or the back of the tibia?
The front?
No, no. Let's look at our anatomy. Soleus and gastroc. Okay, it is always worth it to review anatomy. Always worth it. Okay, here we have the gastroc here, and underneath is the soleus. This like dark purple grayish line is the soleus, and over here they took the gastroc off and they just have the soleus. Can you see that? Can anybody not see that clearly? Let me know if you cannot. So the gastroc is on the posterior surface of the tibia. Here's the tibia bone. See that? Tibia bone, right? Here's the tibia. The soleus is also on what surface of the tibia, Stephanie? Front or back?
The back posterior.
The back. That's right, the posterior, yes. So if they're both on the same surface of the bone, is one an antagonist, or are they both agonist synergists? Are they both, or is one moving in the opposite direction, or they both move in the same direction?
They're both moving in the same direction.
That's right. So can the soleus be the, can you see how that cannot be the antagonist for the gastroc?
Yes.
Yes. And what muscle is on the front of the shin bone, the front of the tibia bone?
I'm
Yeah.
not sure.
Okay, so on the front of the tibia, it's not showing me the, oh, I see tibialis posterior. That would be on the front of the shin, the front of the tibia would be the tibialis anterior, tibialis anterior. Yes. You good with that so far?
Yeah, I'll just have to review it.
Yeah. Yes, that's top layer. That's like the surface layer knowledge, like level 1 knowledge. So you definitely got to get that layer. Definitely got to get that layer. Tibialis anterior, gastroc, and soleus. Let's see. What term is synonymous with the prime mover, agonist or antagonist?
Agonist.
Agonist. Reciprocal inhibition process occurs when which muscle is reciprocal inhibition occurs when which muscle is in action and which muscle is inhibited, the agonist, antagonist, and antagonist, agonist.
The first one.
The first one, yes, but can you say when the agonist is in action, when the antagonist is inhibited?
The agonist
now.
is the one that is doing all the work, which is the one that is
Yes.
flexing, is it? No.
I would say shortening.
Shortening, yes.
Shortening. Yes, yes. And in this case, it's enough to say that it's the agonist, that the agonist is activated, or that the agonist is, you could even say it's contracting because the antagonist is inhibited. So remember, activate and inhibit go together. Activated and inhibited, or action and inhibited go together. Lots of terms that are, like activated is the same as action. Action is the same as shortening. Shortening is the same as concentric. Lots of terms. We just got to practice it. Okay, let's see. Next one. Okay, the muscle action, which is antagonistic to protraction. Where's protraction happen? What bone? What set of bones do we protract and retract?
The
jaw?
No.
the shoulders.
The shoulder blades. The
Yes.
shoulder blades. The shoulder blades. Yes, great. So what's antagonistic to protraction? Adduction, pronation, elevation, or retraction?
Retraction.
Very good, retraction. Okay, which muscle acts as an antagonist to the gastroc during plantar flexion? Stephanie. Tibialis anterior, peroneus brevis, soleus, or plantaris?
Oh, tibialis anterior.
Very good, very good. Okay. Okay. Tension, compression, shearing, and bending. Those are hand techniques, right? Where you apply tension, where you apply compression, you apply shearing, or you bend. Tension, compression, shearing, and bending are examples of what? Reflexive effects, mechanical applications, reciprocal inhibition, or isometric stretching. Which one?
Is it mechanical?
That's right, mechanical applications, mechanical applications. So a mechanical application is a application that you mechanically do to the body using your hand or stone or a cup or something like that. And we're going to go over mechanical and reflexive stuff. Actually, have we done that already? I think we have. Okay, let's see what else we got. Let's just pick some random stuff. Okay, which movement will lengthen the fibers of the trapezius? Which movement will lengthen the fibers of the trapezius? Is it extension of the neck, rotation of the head to the same side ipsilaterally, depression of the scapula, or flexion of the shoulder contralaterally? Contralateral flexion is like this. Which movement will lengthen the fibers? The answer is rotation of the head ipsilaterally. Ipsilateral means if you rotate to the same side. Ipsa means same. So ipsilaterally means rotating to the right, the fibers of the trap lengthen. But I did not know that was the case. Actually, I can feel that, kind of feel that happening. Let me just take a look at what happens to the fibers of the trap. What's that? During ipsilateral rotation of the neck. Let's see what happens. Side flexion of the neck, ipsilateral side of the middle part assists with the ipsilateral, but that doesn't tell us what happens. It says lengthen the fibers of the trapezius, but it doesn't say upper, middle, or lower trapezius. So that's a little tricky. What is the trapezius in neck rotation? Stabilizes the scapula. Upper fibers can elevate and upwardly rotate the scapula. Middle fibers retract the scapula. Lower fibers depress and aid the upper fibers. I see. Okay, so the lower fibers depress the scapula. So what it's saying here is that the depression of the scapula is not the correct answer because the fibers actually contract. The lower fibers of the trap contract to depress the scapula trapezius muscle. The lower fibers of the trap contract to depress the scapula. Here's a pretty good one. Yeah, this one can help. So they don't ask you, is it the upper, is it the middle, or is it the lower fibers? They say, which movement? They say, which movement will lengthen the fibers of the trapezius? And then they just leave you hanging, like to pick the one where there's no shortening at all, where there's only lengthening. So depression of the scapula, these fibers, the lower trapezius, would be shortening in depression of the scapula. And then I think, what are the others? Extension of the neck, flexion of the shoulder contralaterally. So I guess flexing the shoulder contralaterally would lead to shortening of the trapezius muscles over on the opposite side. So you're reaching your right hand across to your left shoulder, and that probably would shorten the muscles of the upper trap on the left side. And then extending the neck, so lifting your nose up to the ceiling, bringing the head back would shorten the upper trapezius fibers. So each answer has a different section of the trap, the upper, middle, and the lower shortening, and only one of them does not shorten. And it turns out that that one is rotation of the head to the same side. So as you rotate your head to the right, the fibers of the middle trap lengthen. I didn't know that, but that's why we practice these questions. As you rotate your head to the left, the fibers of the left middle trap lengthen, and the fibers of the upper trap, they contract. So interesting. Okay. Which of the following best describes a strain? A ligament tear, a joint subluxation, or overstretch injury to a muscle, or a hairline osseous fracture? Which one best describes a strain?
Overstretch injury to a muscle.
That's right. So it's a muscle strain and a joint sprain. Very good. Which substance aids the body in creating scar tissue? Is that keratin, collagen, elastin, or plasma? Keratin, collagen, or elastin, or plasma? Which substance aids the body in creating scar tissue? The answer is collagen. Collagen creates scar tissue, it creates tendons, ligaments, fascia. What type of, no. Sarcomeres. Sarcomeres are composed of what? Actin and myosin filaments that allow muscles to contract. Creatine phosphate cells that limit oxygen to a muscle. Oxytocin and histamine hormones to alert the body to pathogens. Fibroblasts to provide the body with energy. sarcomeres are composed of what? Sarcomere, Z discs, the space between the Z discs, which have these lines on them, these bands. What are these bands called? Filaments. What are the filaments called? Filaments. Actin and myosin filaments. Do you guys just not know, or are you actually like falling asleep over there?
Very hard today.
What?
I didn't know.
You know. Okay. Okay. I wonder if there's any more like sliding. Where's sliding? Here we go. Oh no. Okay. Which of the following statements best describes compensation patterns? A suggested salary that should be paid to employees, comfort aids for special population clients, or a sliding scale to calculate client fees, or postural deviations to protect an area of injury. Compensation patterns. Which one?
I just like the A answer, but it's D.
Yes, postural deviations to protect an area of injury. Compensations. Okay, guys, that's it for tonight. Good work. You guys take a look at this Kinesio 4423 file. I'll probably rename it, but it's kind of like more than one subject in here. So take a look at that. Also, be sure that you go to your March 2023 basics. Look at your intrafusal, extrafusal, as well as the histology of a muscle, right? So you're reviewing the histology of a muscle. And yeah, also look at the efferent and intrafusal and extrafusal muscle fibers from the muscular lecture. And then make sure that you also look at concentric, eccentric, and isometric. Concentric, eccentric, and isometric. I should make this whole thing bigger here. Okay, good job tonight, guys. You hung in there.
Thank you.
Yes,
Very
you
hard
guys did
today.
good. You guys did good. Yeah. All right. So no, there's no class on Thursday. I'll see you guys Tuesday next week. We have 2 more classes. Okay. So Tuesday and
Okay.
Thursday next week.
Thank you.
Okay.
Thank you.
Good night.
All right. You're welcome. You're welcome. Have a great night.